For an age that defies human comprehension, they were the undisputed architects of life on Earth. A dynasty of astonishing diversity, their reign was absolute. Then, 66 million years ago of modern birds were extinguished forever. An unbridgeable chasm of time now separates us from their world. No human eye has ever witnessed the shadow of a Tyrannosaurus fall across the land, nor heard the footfalls of a sauropod herd. We are left to reconstruct their lost kingdom from ghosts of stone and mineral, a task of immense imagination. And because of this distance, our vision of their world has often been a narrow one. The popular image is persistent, a world of steaming jungles and sun-scorched plains, a planet perpetually locked in a sweltering greenhouse state. This is not entirely untrue. The Mesozoic era was, on the whole, a far warmer chapter in Earth's history. But this picture is tragically incomplete. The dinosaurs' success was defined by their adaptability. Their dominion was global. They conquered not only the tropics, but the arid heart of ancient deserts, the labyrinthine gloom of coastal swamps, and even the open ocean. But their empire extended to the planet's most unforgiving frontiers, the polar extremes. Here, in lands of perpetual twilight and months-long nights, a different kind of dinosaur endured. These were not the sluggish giants of popular myth. To survive in the freezing dark, they required radical adaptations, solutions to biological problems that life on Earth continues to solve today. In the resilience of a modern polar bear, we see an echo of the strategies perfected by creatures millions of years before. The key to their survival was a revolution in our understanding, a feature once thought to belong only to their avian descendants. We now know, as an undeniable fact, that a vast and varied number of dinosaur lineages were cloaked not in scales, but in feathers. From simple insulating filaments to complex branching structures, these were not the tools of flight, but of survival. They were the ultimate winter coat, trapping precious body heat against the biting polar wind. Yet this revelation unlocks a deeper, more fundamental mystery. Why did this extraordinary feature, the feather, first evolve? Its initial purpose was not to conquer the skies. The earliest feathered dinosaurs were earthbound. These primitive structures were an answer to a question posed by the environment, a biological innovation born of necessity. In these ancient filaments, we see not the beginning of flight, but the dawn of a new kind of survival, a whisper from a lost world, reminding us that even the most profound transformations often begin with the simple need to stay warm. It is an image etched into our collective imagination, the feather, an icon of flight, a miracle of natural engineering, an evolutionary masterpiece designed for the sky. It is a story we have told ourselves for generations, a simple, elegant line drawn from a reptilian scale to the soaring wing of a bird. And it is a story that is fundamentally wrong. To believe that the feather evolved for the purpose of flight is to misunderstand the very nature of existence. Evolution is not a grand architect, drawing blueprints for a future perfection. It is a blind tinkerer, a relentless editor, working only with the materials at hand for the problems of now. It possesses no foresight, no ultimate goal. An organism with a structure, perhaps resembling a primitive wing, that allows it to glide from tree to tree is not a failure on the path to true flight. If that creature survives, if it finds food and produces offspring, it is an unequivocal success. Its lineage has no obligation to ever conquer the air. The power of flight, the defining characteristic of avian dinosaurs, would not emerge until long after the feather itself first appeared. This simple fact presents an inescapable conclusion. Before the feather was an instrument of aviation, it must have served another purpose in time. To find that purpose, we must travel back in time, to a world both alien and strangely familiar. 220 million years ago, during the Triassic period, the Earth's continents were locked together in a single immense landmass, Pangaea. This was the dawn of the dinosaurs, a time when they emerged from an ancient reptilian group known as the Archosaurs, a venerable dynasty that also gave rise to the crocodiles and the soaring pterosaurs. The Triassic is often painted as a world of unrelenting heat, a planet-spanning desert baked under a harsh sun. While vast swaths of Pangaea's interior were indeed arid badlands, this was a world of extremes. It had its tropical bands, its temperate zones, and, crucialite, to profound, biting cold. As the Triassic gave way to the Jurassic, the planet convulsed. A mass extinction event, though smaller than the one that would later seal the dinosaurs' fate, ripped through the global ecosystem. Many of the dominant reptile groups were wiped from existence. But from this crucible, the dinosaurs emerged not only intact, but poised for world domination. For decades, their survival was a mystery. Now, we believe the answer lies not in the heat, but in the ice. The key to their triumph was not their ferocity, but a secret weapon forged in that unexpected cold. In the ancient rock of what is now China's Zhongar Basin, geologists have read a forgotten story. The stones bear the unmistakable scars of ancient ice movement, the grinding signature of glaciers. During the late Triassic, this entire region lay deep within the Arctic Circle, and it is here, in these frigid high latitudes, that the fossils of the earliest dinosaurs are found in greatest abundance, while they remain strangely scarce in the equatorial regions. They were not creatures of the scorching desert, they were creatures of the cold. Independent research confirms that the genetic architecture for feathers is far more ancient than once believed. The pieces of the puzzle click into place, revealing a startling new image. The feather was not born of a dream of flight, it was born of the shiver. The first ament, a delicate coat against the polar night, a layer of insulation that allowed these pioneering dinosaurs to thrive where their rivals froze. Survival was the spark. But once this evolutionary toolkit existed, it could be repurposed, co-opted by different lineages for a multitude of new roles. Over millions of years, this simple insulating layer would be sculpted by natural selection into a dazzling array of forms. It became a canvas for display, used in elaborate courtship rituals. It became a cloak for camouflage, breaking up an animal's outline in the dappled forest light. It was used for brooding to keep eggs warm. We see this pattern written in the fossil record. The smaller, mole covering for a smaller body that loses heat more rapidly. Yet, as the dinosaurs grew to titanic proportions, the feathers seemed to record greater concern than the cold. Its insulating coat, so essential to its distant ancestors, may have become a liability, a relic of a colder, more distant past. And finally, on one particular branch of the dinosaur family tree, this structure, originally designed for warmth, was reshaped into an airfoil. It became longer, stiffer, asymmetrical. It learned to catch the wind. The simple need to survive a cold night had, through 100 million years of tinkering, unlocked the sky. The story of the feather is the story of evolution itself, a winding, unpredictable path of accident and necessity, where the most profound innovations arise not from a grand design, but from the simple, urgent need to endure. The image of Tyrannosaurus rex is etched into our collective consciousness, a colossal reptilian predator, its hide a tapestry of formidable scales. It is the tyrant lizard king. Yet the foundations of this image are crumbling, challenged by startling discoveries that force us to reconsider the nature of this iconic animal. The truth begins not with Tyrannosaurus itself, but with its extended family, a lineage where feathers were not the exception, but the rule. We know that many of its theropod cousins were cloaked in intricate plumage, from the smallest hunters to giants that rivaled the king. For Tyrannosaurus rex, however, the evidence tells a different, more complex story. The fossil record has yielded not the ghostly impressions of feathers, but the tangible traces of skin. These fossilized fragments, unearthed from sites in Montana and Alberta, reveal a creature covered in fine, yet entirely covered in the dense plumage of its ancestors. Yet this does not close the book. It is entirely probable that the tyrant king retained a whisper of its feathered heritage. Paleontologists now suspect that a sparse coat of downy filaments, known as protofeathers, may have adorned its body, particularly along the neck and back. This wasn't a coat for flight or for show, but a vestigial remnant, a ghost of an evolutionary past. The reason for this dramatic loss of plumage seems tied to two inescapable facts: its immense size and the sweltering world it inhabited. In the humid, tropical environment of late Cretaceous North America, a full coat of insulating feathers on a 12-meter, 9-ton animal would have been a fatal liability, a furnace of its own making. But the story of the Tyrannosaurs is a story of adaptation across immense spans of time and geography. To understand the king, we must first look to its older, stranger relatives. We must travel back 130 million years to the ancient forests of northeastern China and meet a creature that defies the simple narrative of big equals scaly. Its name is Yutyrannus. Yutyrannus was a proceratosaurid tyrannosauroid, a branch on the family tree that diverged long before the rise of T-Rex. It was a formidable animal, stretching 9 meters from snout to tail. As a paleontologist, one rarely expects to find the complete skeleton of such a large creature. The ravages of time typically scatter the bones, leaving only fragments. The entirety. But against all odds, 3 nearly complete skeletons of Yutyrannus were unearthed, and with them, a revelation. Preserved along their bones were the unmistakable impressions of. Here was a giant, a predator of immense scale, yet it was fully feathered. The reason lies not in its size, but in its location. During the early Cretaceous, the part of China where Yutyrannus lived was situated much farther north, close to the Arctic Circle. It was a temperate world of harsh seasons and significant cold. For Yutyrannus, this dense, insulating coat was not a liability. It was an essential tool for survival. Was this feathered giant merely a cold weather anomaly, a singular adaptation in a remote corner of the world? The evidence suggests not. To find the next piece of the puzzle, we must leap forward in time and travel to the very top of the world. Here, we meet a much closer relative of T-Rex, Nanuqsaurus. Its name means polar bear lizard, a title earned from the brutal environment it called home. This dinosaur was a true tyrannosaurid, a direct cousin to the king. Its fossils were first discovered in 2006, locked in the frozen earth of Alaska's North Slope. Initially, the fragmented bones were thought to belong to a known species, perhaps a Gorgosaurus. But by 2014, a more detailed analysis revealed telltale differences. This was something new, a predator uniquely adapted to the extreme north. The world Nanuqsaurus inhabited was one of the most challenging on the planet. Cretaceous Alaska was a land of prolonged, freezing dark, would have needed exceptional but a biological necessity for Nanuqsaurus. This polar tyrant also hints at a different kind of behavior. The harsh, unforgiving landscape may have driven Nanuqsaurus to hunt in cooperative groups. This hypothesis of pack-hunting tyrannosaurs has been suggested before for other species, though it remains a subject of intense debate. But in the Arctic darkness, a coordinated attack would have been the most effective way to bring down the formidable prey that share the polar forests. The tales of Yutyrannus and Nanuqsaurus, the feathered tyrant of the ancient East and the polar ghost of the North, do not rewrite the story of Tyrannosaurus rex into one of a fluffy giant. Instead, they illuminate the incredible versatility of its dynasty. They reveal a lineage of apex predators capable of conquering any climate, modifying their own bodies, their very skin, to master narrative. Each bone fragment, each feather impression, is a word in a story that reminds us that our understanding is never complete, and the true image of these lost worlds is only ever a discovery away from changing forever. In the grand lineage of the horned dinosaurs, the ceratopsians, one creature stands apart, a rebel against its own anatomical blueprint. While Enosaurus, the thick-nosed lizard, chose a different path. Where a sharp nasal horn should be, it developed a colossal flattened shield of bone, a massive boss that served less as a piercing weapon and more as a living battering ram. This ancient beast roamed the high latitudes of what is now Alaska, a world of prolonged darkness and chilling temperatures. This extreme environment has ignited a fierce debate among paleontologists, a question that cuts to the very heart of how we imagine these animals. Was Pachyrhinosaurus covered in rugged reptilian scales, or was it cloaked in a thick mantle of primitive feathers? The argument for a feathered giant is not without its foundations. Evidence from distant, diminutive cousins, such as Psittacosaurus, reveals the ponents suggest that if these basal ceratopsians possessed such integument, it's plausible their larger, cold-adapted descendants would have evolved a more extensive, insulating coat. Yet the stone itself tells a conflicting story. When we look at the giants of the family, the fossil record has been unambiguous. Every skin impression found from large ceratopsians reveals not feathers, but an armor of large, hexagonal scales. Fossil impressions of its cousin, Triceratops, paint a picture of a creature with a tough, pebbled hide, more akin to a modern rhinoceros than a bird. To base the appearance of a 7-ton behemoth on the quills of a creature a fraction of its size is a leap of faith many scientists are unwilling to take. The most compelling piece of this puzzle, however, comes not from Pachyrhinosaurus itself, but from its neighbor. It shared this challenging Arctic ecosystem with another giant herbivore, the hadrosaur Edmontosaurus. On rare, miraculous occasions, the remains of dinosaurs are preserved with such astonishing fidelity that they are dubbed mummies. These are not merely skeletons, but time capsules that retain fossilized skin, tissue, and integument. An Edmontosaurus mummy has been discovered, and its testimony is clear. It was unequivocally scaly. This creature, living in the very same polar environment, thrived without a coat of feathers. If a hadrosaur could endure the Alaskan cold with only scales for protection, it stands to reason that the powerfully built Pachyrhinosaurus could have done the same. But the story of polar dinosaurs is not confined to the north. To truly understand life at the extremes, we must journey from one end of the Earth to the other, to the vast, frozen continent of Antarctica. Here, from the frozen rock, emerges a predator from a much earlier age, Cryolophosaurus, the frozen crested lizard. Measuring up to 7 meters in length, it was one of the largest carnivores of the early Jurassic, a formidable hunter in a land of ice and shadow. Its most striking feature was a delicate, forward-curving fan of bone that rose from between its eyes, an ornament of unnevhebs brightly colored in males to signal their fitness to potential mates in the polar twilight. To survive the long, dark Antarctic winters, it is widely believed that Cryolophosaurus was insulated by a primitive coat of downy filaments, protofeathers, that would have trapped body heat against a relentless cold. Yet this creature presents a deeper mystery, a puzzle of identity. Its place in the dinosaur family tree is a subject of intense scientific contention. Its femur is characteristic of early theropods, but its skull and other features bear a striking resemblance to a later, more advanced group known as the Tetanurae. Some studies have placed it firmly within this group, while others have proposed it as a potential ancestor to the mighty Allosaurids. Its skeleton is a mosaic of conflicting clues. A landmark study in the year 2020 offered a new hypothesis, placing it within the group Avarostra as a close relative of the double-crested Dilophosaurid. From the scaly titans of the Arctic to the feather-cloaked hunters of the Antarctic, the polar dinosaurs challenge our preconceptions. They are ghosts in the stone, leaving behind fragmented clues that both illuminate and obscure their reality. Each fossil is a single, whispered word from an epic story we can never fully read, a testament to life's tenacity in the most unforgiving corners of our planet's deep past. To comprehend the planet's frozen past, one might turn to the 4th chapter of Prehistoric Planet, titled Ice Worlds, a vision forged from the crucible of modern data. Yet, to appreciate the journey of our understanding, we must also look back to a landmark production from 1999, the 5th installment of Walking with Dinosaurs, Spirits of the Ice Forest. While a monumental achievement for its time, its narrative is now a fossil in its own right, filled with depictions that no longer align with contemporary scientific consensus. The unyielding march of discovery renders even our most cherished visions obsolete. Each attempt to reconstruct these lost worlds is not a final truth, but a fleeting snapshot, a reflection of our own evolving search for a past that remains forever just beyond our grasp.